All right, so let's suppose, and this is going to be number 31, that's on page, and you need to know the terminology as well. So 31, and that's on page 892. All right, so here's 31. You have you have 4z to the 10th, and that's a z, negative 6z to the 7th, and z cubed. So if this was on your test, and the directions will say simplify. So what would you do here to simplify this? What property would you use? Anybody? What? Or property / rule. What would you use here? Come on, you have a test coming up. Not the power rule, the product rule. The product rule. The power rule you would use if you have something in parentheses all raised to a power other than 1. So if you look at this parentheses right here, what's this exponent out here? 1. This parentheses, what's this exponent out here? 1. This parentheses, what's that exponent out here? 1. If it was something other than 1, then that would be called the power rule that you would have to use at some point. But everything's raised to the first power, so you don't use a power rule here. In fact, this is an easy kind, since the outer exponent is 1. What operation are you using here? What's that operation when you read this? You read this as 4 what? Times z to the 10th, and tell me what else? Times negative 6 times z to the 7th times z cubed. That's important to know. Knowing that will sometimes help you, for the most part, it will help you to know what to do. But if you know the operations that's being performed here, then you're going to struggle with these. All right, so use a product rule. Now, based on what we talked about the other day, what part of this should you do first? You don't have to, but what part is usually that I usually did first? Nope, there are no combined like terms here. You're not adding anything. To combine like terms, you're either adding or subtracting. We're multiplying. So that, okay, what are those called? Space? No. I'm looking for another word. Coefficient. Okay, so you need to write that word down. No one remembered it. Write it down. So you multiply the coefficients first. So what's this coefficient in this parentheses? 4. What's the coefficient over here? What's the coefficient over here? 1. What's 4 times negative 6 times 1? Negative 24. All right, then remember the product rule says that when you multiply like bases, your answer is going to be that base raised to, and what do you do with those exponents? Add them. So there'll be z to what power? Huh? 20. So that's your answer. All right, so that's 31. Okay, so notice that today you struggle with this. Don't struggle with this on test day. Make sure you can do this. All right, 43. You had this one. You have negative 7, a squared, b to the 5th, c, all raised to the 2nd power. All right. So remember, here I use the product rule. All right. So what are you going to do here? Multiply everything by 2, so you're saying negative 7 times 2.
Yeah, well, negative 7 by itself, no, because you're doing negative 7 times negative 7, because you have the power.
Right, so what rule am I using here? The power rule. That's the power rule. And the power rule says I take each factor that's inside that parentheses and I raise it to that power. So remember that middle step that we did was we said, all right, the first factor I see is negative 7. So I'm going to raise negative 7 to what power? a second. The next thing I see is what? A squared. I've got to raise that to what power? A second. The next factor I see is b to the fifth. I've got to raise that to what power? C. A second. The next factor I see is a c. I've got to raise that to what power? Second. So if you do right in that step, you write in that step. But the power rule says when you have a product, when you have a product raised to a power, the power rule, and this is the power of a product, so I should say power of a product. So there's a power of a product rule. So you have a product that's inside the parentheses, right? And it's a product because everything's being multiplied. -7 times a squared times b to the fifth times c. But that product is being raised to a what? Power, though, right? You use the word power in there. So the power of a product says I take each factor and I raise it to that power, to that exponent. So what's a -7 squared? 49. What's now this right here? I'm gonna kind of draw lines to them. That is the power rule by itself. What's a squared squared? The power rule says when you have a power raised to power, what do you do to those powers? Okay. So what's that? A to the fourth. What's the next one? What's the next one? C to the second. Because this right here, that's understood to be what exponent right here? 1. And so 1 times 2 is 2. Okay? All right. So that's 43. 82 looks like this. All right, 82, you have y squared z squared times y to the 15th z to the 13th. All right, again, what rule am I using here? The product rule. Product rule. In fact, if you look at all the coefficients are what in both sets of parentheses? 1. So that one's easier than number 31. What's the answer?
Is that 15?
Yeah, that's 15 and 13. Y to the 17th, z to the 15th. So that's 82. 94. All right, 94, you have 5x to the 9th divided by x. What rule are you going to use here? What's that rule called? Quotient rule. That's a quotient rule. So the quotient rule says that when you divide like bases, your answer would be that base raised to, and what do you do to those exponents? You subtract them. So that middle step, or that next step, if you want to do the work, of course you can just tell me the answer is, but if you want to do the work, you'd say 5x to the 9 minus 1, which is 5x to the 8th power. All right, there's 94. All right, and the next one. So let's look at 98. All right, 98, you have 2ab raised to the 5th. Okay, what rule are you going to use here? What's that rule called? Power of a product. Good. So you have a product being raised to a power. So that's a power of a product rule. All right, now remember that next step. Sometimes that next step is what some of you need to be doing. But you can go from there to the answer. But if you struggle with this, you may want to do that next step. So the power product rule says I take each factor, and what's that first factor that you see? And I raise it to what power? 5th. And I take the next factor, which is what? And I raise it to the 5th power. And I take the next one, which is b, and I raise it to the 5th power. Now, what will I use next? The power rule, because this is understood to be a 1, right? So 1 times 5 is 5.
That's a 2.
Yeah, but that exponent right here, power raised to power.
Oh, I couldn't
Yeah.
see that.
So see right here that A's being raised to what power right here? That's in the parentheses. 1. B's being raised to what power? 1. So 1 times 5 is 5. So that's 2 to the 5th. A to the what? 5th. B to the what? 5th. All right. Now one more step, because you can't leave it as 2 to the 5th, because you can easily, you have your calculator, and even if you didn't have your calculator, it's easy to do. 2 to the 5th means 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is, and 16 times 2, which is 32. So that's 32. A to the 5th, B to the 5th. Okay. 104. You have 5 x to the 12th power y to the 13th divided by x to the 5th y to the 7th. What rule are you going to use here? Quotient rule. Good. Quotient rule. So that middle step, or the next step, the coefficient here is 5, the coefficient here is 1, right? Okay. So in terms of coefficients, there's not much I can do there. It's just going to be a 5 over 1, which is what? 5. So I get 5. All right, now you can use the quotient rule with the variables. So it's x to the 12th subtract what? 5, because remember, when you divide like bases, you do it as exponents. You subtract them. Y to the 13th minus 7, where you subtract exponents. So the answer is going to be 5 what?
7, y 6.
Y6? Yes. Yep. Okay. All right. That's the answer to that one. Okay, 102. You have 2ab divided by 6yz, all raised to the 4th power. All right. So what rule are you going to use here? What is that rule called? Power of a quotient. Good. You have a quotient this time. See, this right here was power of a product, because that's a product. Here, when you do a division, that's a quotient. So it's a power of a quotient. That was that last thing we talked about last class period. All right, and remember how we did the power of a quotient. The power of a quotient, this is what we did. We took the numerator and raised it to that power, so we did this. And we took the denominator and raised it to that power. All right, so that's first step we did, first step. So the power of a quotient, you take the numerator, raise it to that power, and then take the denominator, raise it to that power. And then notice when we did this, it now becomes power of a what? Product. So I went from power of a quotient to, and each one of these would be a power of a product. Okay. All right, now let's do with the numerator. What's 2 to the 4th? 16. What's a to the 1st raised to the 4th? Okay. What's b to the 1st raised to the 4th? All right, divided by. Now you may use your you probably will need your calculator with this one. 6 to the 4th on your calculator. What is that? 1,296. Y to what power? Z to what power? All right. Now, that's where we're at. Now compare that with 104. 104, we used the quotient rule because I had the same variables in the numerator and the denominator. Am I going to use the quotient rule at all here? No. But can I simplify the coefficients? Yes. For one thing, they're both divisible by 2. They're both even, right? So let's do the 2 first and see what happens. What's 16 divided by 2? All right, so I'm doing this right here. I'm looking at 16 divided by 1,296. So that's 8 divided by, and then 1,296 divided by 2. What's that? Use your calculator. 1,296 divided by 2.
648.
Okay. So can I still reduce this? Yes, they're both divisible by 2. 8 divided by 2 is 4. What's 648 divided by 2? 324? Okay. So they're still divisible by 2, right? 4 divided by 2? 324 divided by 2?
162. Thank you.
They're still divisible by 2. So that's 1 divided by what? 81? All right, so this the coefficients reduced to 1 over 81. So that means this. That means that in the numerator, where I have that a to the fourth, b to the fourth, that coefficient is going to be a what? A 1. But do we need to put that 1 there? No. The denominator is going to have what coefficient? 81, and then what's the rest? Y to the fourth, z to the fourth. Okay, so that will be the answer for that one. Now, I want to mention one thing here. I'll do the same problem, and I want you to notice something. I want you to go back to that same problem. Okay, watch what happens when we look at it this way. Okay, same problem. All right, now if that 4 wasn't there, then that would even be the quotient rule, right? Because there's no variables, the same variables aren't located in both numerator and denominator. But I can do what to the 2 to the 6? Reduce. So right off the bat, I can say this is, I'm going to do this here. I can say this is 1 and this is what? 3. Okay? So the numerator is just AB. The denominator is what? 3yz. But all that now, though, is being raised to what power? 4. And now let's use the power of a quotient. So notice what I did. All I did was do what to the 2 and the 6? Reduce. So AB to the 4th is just what? 3 to the 4th is? Y to the 4th is? Z to the 4th is? You get the same answer. So if you can reduce at the beginning, you can go ahead and do it. It makes things a lot easier. See this? It makes things a lot easier. All right, now let's look at this example. Suppose you had, suppose you had negative 6 x squared y cubed divided by 5. Let's make that x to the 4th. I'm sorry. X to the 4th. X, z to the 5th. And all that's being squared. All right. Okay, so if that was your test, what would be an approach you would take? Come on, try something. Huh? Come on, guys. Okay, so you would raise, so basically, you first of all, you're looking at this in terms of power of a quotient. So you take the numerator, and you're going to raise it to the second power, right? So my numerator is this. My denominator is this. And I also have to raise it what power? Second. All right, so that's a legitimate step you can do. Then now we're going to, now remember I use the power of a quotient here. To go from here to here, that's the power of a quotient. Now I'm going to use the power of a product. So what's negative 6 squared? 36. Because a negative 6 times a negative 6 is a positive 36. What's x to the 4th squared? X to the 8. Because when you have a power raised to power, that's a power rule. When you have a power raised to power, you do what to those exponents? Multiply. Y to the 3rd squared is what? Y to the 6th. So that's the numerator. Let's go to the denominator. What's 5 squared? What's x to the 1st squared? Good. What's z to the 5th squared? All right, so that's where I'm at. Okay, no big deal at this point. Now, am I done, though? Because the direction's set to simplify. Why not? Tell me. All right, so what rule can I use at this point? The quotient rule. I can use a quotient rule with which variables? The x. So this right here, I'm going to circle the x's. So I'm going to get this. I'm going to get, in the numerator, I'm going to get 36 x to the 8 subtract what? 2 y to the 6. And what's the only thing left in the denominator? 25 z to the 10th. That's the only thing left in the denominator. And all you have to do is just tell me what 8 minus 2 is. What's 8 minus 2? 6. So the answer then is 36. The numerator is 36 x to the 6 y to the 6 divided by 25 z to the 10th. That's it. Right. So the only thing I could have used a quotient rule with at this point was the x's. And so remember, it's the quotient rule says it's the top exponent minus the bottom. So in the numerator, you're going to say x to the 8 subtract 6. All right, now, one more thing that we didn't talk about that we need to that's in this section is this idea. Okay, listen carefully for this. It's not difficult. Without using a calculator, what do you think, actually you couldn't use a calculator with this anyway, with the one I'm about to do. Simplify x to the 0 power. What do you think x to the 0 power equals to?
0.
0?
Mm-hmm.
Good. Anybody else? You think it's equal to 1? Anyone else?
It's gotta be 0 because it's multiplied times 0. Everything multiplied times 0 is 0.
That is a true statement. 0 times any number is 0. Okay. All right. So let's look at this idea then. What is x to the 8th divided by x to the 8th? That's 1, because anything divided by itself is 1, right? Okay. But what if I use a quotient rule? Could I use a quotient rule here? Yeah. So according to the quotient rule, that's just going to be x to the 8th, what? Subtract 8. But what's 8 subtract 8? 0. So x to the 0, if this side's the same, and we agree those are the same because there's a quotient rule, then x to the 0 has to equal what? 1. X to the 0 has to equal 1. So this is going to be called the 0 exponent rule. Zero exponent rule. All right, and before we go on, someone mentioned that anything times 0 is 0. All right, but that's not what this means. X to the 0 power doesn't mean multiplied by 0. So remember what you got to remember what we're saying here. So if I have 3 squared, does that mean multiply 2 times 3? No, that means I take the base and I multiply it by itself that many times. All right, over here, the base is x. So if I had, let's say, 4 to the 0, that's going to be 3 times 3, which is 9. 4 to the 0, that means I take the base and I multiply it by itself 0 times. So it doesn't mean 4 times 0. Okay? So and that doesn't make any sense. So 4 to the 0, when I say multiply by itself 0 times, what does that mean?
That your answer in your base is still going to remain 4.
No, the answer is not 4. We just saw that 4 to the 0 power is what? 1. 1. Okay, so the 0 exponent rule then says this. So if you have a base, as long as it's 9 0, so 8 cannot equal 0, and it's raised to the 0 power, then that's going to equal what number? 1. All right. And so you should now see, based on what we did here, why that's equal to 1. All right, so that's going to be our definition, the rule. So any non-zero number raised to the 0 power is going to be equal to what? 1. Okay, so anything raised to the 0 power is 1. All right, so knowing that now, let's look at number 66. Oh, I'm sorry, let's look at 64 first. Okay, 64, you have 23 to the 0 power. Very quick, what's that equal to?
1.
1. And if you forget, especially if the base is a number, use your calculator. On your calculator, say 23 raised to the 0 power and press equal, you're going to get a 1. All right, 66. Look what this looks like. Don't make it difficult. What's that equal to?
1.
1 as well. Because what's being raised to the 0 power? No, that's not 44. It looks like 44. That's 44y.
That's why I thought.
No, it's
44 down to.
no. That's y. 4y. So 4y raised to 0 power is equal to what?
1.
1. 68.
1.
No. You got to be careful. What's this equal to? Negative 2. That's equal to negative 2. What's the only thing being raised to the 0 power? The x. So this right here that I'm underlining, that is 1. This right here is 1. So this becomes negative 2 times 1, which is what? Negative 2. 70. You have negative 3 to the 0 plus 4 to the 0. Why 2?
Oh, 1.
Yeah, 2. Yeah, because
Okay, now you see some of you forgetting. Some of you are getting.
1 plus.
Yep, some of you are forgetting. You're saying this right here is 1, right? That's what some of you said. That's not true. That right here is not 1. Remember we talked about the fact before. Now listen carefully. Negative 3 to the second power. Let's look at that first. What's negative 3 to the second power? Is that 9? No, that's not 9. That's what? Negative 9. Because we talked about the fact that we compared these two. If I wanted negative 3 to be raised to the second power, I need to put that negative 3 where? In parentheses. That means negative 3 times negative 3, which is 9. This means the only thing being squared here is not negative 3, but what? 3. So 3 squared is 9, so this becomes a negative 9. So what's being raised to the 0 power here? Is it negative 3 or is it 3? 3 only. So what's 3 to the 0 power? 1, so this becomes what? Negative 1 plus, and what's 4 to the 0 power? And so what's negative 1 plus 1? 0. So the answer is 0. Okay. All right, 96. 96. All right, 96, you have 5ab to the 0. What's that equal to? 1. The whole thing's being raised to 0. So that's 1. 100. 7 squared minus 7 to the 0. What do you think that's equal to?
48.
48. So 7 squared is 49. 7 to 0 is 1. So that is 48. Okay? All right, so that takes care of that section. So remember, the last thing we did was the zero exponent rule. That was the last thing. All right, and so if you look at your study guide, there are 12 sections on 12.1. So it's just like 2, 4, 6, 7 problems on 12.1 in your test. All right? So don't make it difficult. It's not that difficult. Just need to know the rules, and you need to know how to use them. And then the only thing that's new that we need to talk about is 12.2 parts A and B. Now there's a part C, but that's going to be on test 4. 12.2 part A and B. So let's start talking about 12.2, section 12.2. All right, so here's how we're going to approach 12.2. In 12.1, all the exponents were what kind of numbers? And what I mean by that is, were they all positive? Were some positive, negative? Talk about exponents. They were all positive. Well, that's not always the case. You can have exponents that are negative. So we need to talk about what to do with negative exponents. So that's 12.2. So 12.2 talks about negative exponents. Okay, so this is section 12.2. All right, so 12.2, the first thing we're going to talk about is negative exponents. All right, so let's start talking about negative exponents because there's some rules you got to remember. Just a few rules. Now, all the rules you just learned, you're still going to use. The quotient rule, the product rule, you're still going to use them. But there's a couple more rules you got to add here, and that's the ones with negative exponents. Just two rules. Before we get to those, though, let's look at what this would be. What do you think? 3 squared is? Okay. What do you think 3 to the negative second power is? You think it's negative 9? All right. Well, use your calculator. Tell me what 3 to the negative second power is in your calculator.
It should be 9.
Okay, so 3 to the negative second power in your calculator. 3 raised to the negative second power equals its decimal, right? So obviously it's not 9. Okay, that's a number less than 1. 0.11111. But how do you convert this decimal to a fraction?
Second PRB.
Second PRB, press equal. What do you get? 1/9. So 3 to the negative second power is 1/9. Now someone said negative. Well, let me just remind you about this. The base is what kind of number? Positive or negative? Positive. A positive number raised to any power, whether it's positive, negative, or 0, is always a positive number. A positive number raised to any power is always going to be positive. So that had to be a positive number. All right, so we get that that's supposed to be 1/9, right? Well, we can get 1/9. You see where if this, where we had 3 squared was 9, correct? So do y'all agree that this right here is this? Okay, all right, let's look at this one. And we're going to come back and we're going to see what that rule is. Suppose I had 4 to the negative third power. Use your calculator. Tell me what that is. It better be positive though, right? Because 4 is a positive number.
164.
1/64. Okay. But 64, I just want you to remember this. 64 is really 4 to what power? The third. 64 is really 4 to the third power. So I want you to notice what's happening here. 3 to the negative second power, the exponent's negative. So what you want to do is always rewrite the exponents from negative to positive. You want to rewrite the exponents from a negative exponent. What kind of exponent? Positive. All right. So 3 to the negative second power, I can write as 1/3 to the positive second power. 4 to the negative third power, I can write as 1/4 to the third power. So knowing that, then what do you think x to the a to the negative b power is? 1/a to the b power. So that's called the negative exponent rule. Okay, negative exponent rule. So whenever you have a base raised to negative power, you got to make that power what kind of number? Positive. So you're going to, according to the rule, it's going to be 1 over a to the b power. Okay? Now, let's look at this. Suppose you had this. Suppose you had 1 over 3 to the negative second power. 1 over 3 to the negative second power. What do you think that equals to? Okay, all right, good point. All right. So what she did was she did this. She remembered something from what we just did, also found something from a previous course. So this is 1 over, and then 3 to the negative second power, we just saw that's 1 over what? Yes, 9. Yes, 3 over 9. But from a previous course, how do you divide fractions? You change this division, what kind of problem? So that's 1 times the reciprocal of 1/9. What's the reciprocal of 1/9? So what's the answer? All right. And you agree that 9 is 3 squared? So 1 over 3 to the negative second power, remember, you always want to make those exponents what kind of numbers? Positive. So I want you to notice something. Where is the exponent negative in this case? In the denominator. So to make it positive, you got to rewrite the base, and you got to put the base where? In the numerator. So when you change from the numerator to the denominator, the exponent, the sign of the exponent changes. So this right here is negative exponent rule number 1, and this will be negative exponent rule number 2. So if you have 1 over a to negative b, 1 over a to negative b, then what is that as a positive exponent? It's just what? A to the b power. A to the b power. All right. So knowing those two rules and all the rules we did a while ago in the previous section, we can now start talking about some problems here. All right, it's not difficult. All right, so we're going to start with an easy one. Let's start with this one. Simplify. All right, simplify. Don't make it difficult. Okay, so I'm going to just write this example for right now. What if I had this? What if I had x to the 8th power divided by x to the negative 2nd power? Let's start with this for right now. What rule can I use here? Yes. So the best thing to do is try to use the previous section's rules first. So don't use this first here. Don't say, well, I'm going to make that exponent positive. Don't do that yet. Don't do that yet. Always do that at the end. Always do it at the end. So I'm going to use the quotient rule first, right? Okay? So that's going to be x to the 8 subtract a what? Negative 2. But what is 8 subtract negative 2? Positive 10, because that's 8 plus 2, right? So the answer is x to the what? 10th power. That's the answer. Now, that's the best approach to take here. Now, what if you did say, well, I'm gonna make that exponent positive to begin with? That's fine. It makes it a little bit difficult for you. It's a little bit more challenging, but it's doable. So here's what you do. So where is the exponent negative? Where must you put it? In the numerator. So this becomes x to the 8th times x to the what? 2nd. Okay?
And what rule I'm going to use now? Product rule. So, and remember, product rule, when you multiply division, what those exponents? What's 8 plus 2? 10. So it did not matter whether you used the quotient rule or the product rule, but to use the product rule, I have to first of all rewrite that negative exponent as a positive exponent. So it didn't matter which approach you take. Sometimes it helps though if you know both approaches. Okay? So that's the idea you're gonna deal with as we go through this. All right, so let's look at this one. So this is going to be number 2 on page 901. All right. So we have 6 to the negative second power. 6 to the negative second power. Make the exponent positive. According to what we just talked about with the negative exponent rule, I could rewrite this as what? 1 over 6 to what power? The second. Good. And what's 6 in the second? 1 over 36. So that's your answer. Okay? No. Sometimes you need to, though. And here you didn't need to. Number 4. We have, well, before we do number 4, let's do this first. Let's write this example. Suppose the example is this. 8 x to the negative 5th power. 8 x to the negative 5th power. All right, remember, I have negative exponent, right? I've got to make that exponent what? All right, what's the only thing being raised to the negative 5th power? X. All right, that's the only thing I deal with then. So what do you think the answer is? Anybody else? 8 divided by x to the 5th. Because 8's being raised to what power? First, that's a positive exponent. So it stays where it is. The only things you move, if you're going to move the negative exponents, the only thing you move are the negative exponents. What's being raised to the negative 5th power? X only. X only. A's being raised to, not the negative 5th, A's being raised to what power? The first. So the answer is just, so this is what you're going to move. So it's in the numerator, you're going to put it where? In the denominator. So you go over x to the 4th. Okay? All right, let's look at number 4. Now don't make number 4 difficult. We have 7x to the negative 3rd power. 7x to the negative 3rd power. Now this is probably where you may want to put in that little step. Your work, so to speak. What's being raised to negative power? 7x. So how are you going to rewrite this? 1 over, put in that 7x to the 3rd. So write in that step. Remember someone said, can you skip that step in number 2? Yes, but this one you may not want to. 1 over 7x to the 3rd. So now that exponent positive? Yes. Now, we're going to use the power of a product here. What's 7 to the 3rd? Use your calculator. What's 7 to the 3rd power? So what's the answer? X to the 3rd. Yes, so don't forget, the numerator is still 1 now. So 1 divided by 343 x to the 3rd. Remember 7x to the 3rd, one approach to think about is 7x times 7x times 7x, right? 7 times 7 times 7 is 343. X times x times x is x to the 3rd. So that's 4. All right, let's look at number 10. 1 divided by q to the negative 5th. That's not difficult. What's the answer? Q to the 5th. Y'all agree? Because remember, the rule right here says 1 over a to the negative b is just what? Is just a to the b. 1 over q to the negative 5th is just what? Q to the 5th. All Now, don't make number 12 difficult. This is what you have. R to the negative fifth, S to the negative second. So think about the answer. What do you think?
R to the fifth over S to the second.
No. Nope. Nope.
Like,
That's an S at the bottom.
yeah, but it wouldn't be like a little division thing, I don't know what it's called. Like this.
Okay, you're forgetting the rule. You're forgetting the rule. What's being raised to the negative power? R is being raised to negative power. Where is it? Where do you put it? In the denominator. Why did y'all forget this already? That's what we've been doing. What else is being raised to negative power? S. Say S. S. Where do I put it? In the numerator. So my answer is going to be in the numerator. What will my answer be? S squared. In the denominator, what will my answer be? 1 to the fifth. You're forgetting everything we just talked about. Okay? If the exponent is negative in the denominator, where do you bring the base to? Numerator. If the exponent is negative in the numerator, where do you bring the base to? The denominator. Y divided by y to the negative third. Now, there are a couple approaches you can take here, so let's think about this. That's one approach. Okay, so that's one approach. So her approach is she wants to go directly to the negative exponent first. She sees a negative exponent. She wants to deal with that first. That's fine. What's being raised to negative third power? Okay, so where do you bring that y to? Numerator. So that's going to be y times y to the what? Third. And then what rule are you going to use now? What's that rule called from the previous section? Product rule. So what's the answer? Okay, so that's one thing you could have used. What else could someone have done first? Quotient rule. So we divide like base, you do with those exponents. Subtract them. So the quotient rule then, you would say, y, and this y is being raised to what power? 1. So y to the first, subtract a what though? Negative 3. Okay, good. So you got to be careful using the quotient rule here, because the exponent in the denominator is negative. But what is subtracting negative 3? If you don't remember your rules from last semester, use your calculator. 1 subtract the negative 3. What does that give you? 4. So you get y to the fourth. So either approach is fine. 16. So get 16. But not difficult as long as you know those two rules. Those extra rules. And you also have to remember the stuff from last section. Okay. X to the negative 4, subtract x to the negative 1. Now, there are different approaches you can take. It doesn't matter what approach you take, as long as it's mathematically correct. What's one approach that you may want to take? Okay, you want to use the quotient rule first? That's fine. You can use the quotient rule, right? That's one thing you can do. All right, so when using quotient rule, though, you got to say x to the exponents in the numerator. What's the exponent in the numerator? Very good. Subtract what exponent? Yes. Now, on your calculator, because for the most part, some of you are still struggling with signed numbers. Use your calculator if you are. What's negative 4 subtract a negative 1? Negative 3. So this is x what power? All right, so that's where we're at. Is that the answer? No, the directions will say simplify and make sure that your final answer has what kind of exponents? Positive. So what's the answer? 1 over x to the third power. That's it. So that's one approach. So the first approach was to use a quotient rule. What's another approach you could have taken? Sure. No, you're forgetting what we just did with, yes, so you're trying to use this one here, number 12. So you're trying to use that, which is what some of you struggled with when we started talking about number 12. So what's being raised to the negative fourth power here? X. So if you want, what she's trying to do for that other approach is to make the exponent positive the next step. So you got to rewrite this x located where? In the denominator. So x to the negative fourth, that's in the numerator, I'm going to put it where? In the denominator. And so when you move from numerator to denominator, the sign of the exponent changes. The denominator, x to the negative 1, I'm going to bring it where? The numerator. And so it just becomes x, right? Okay, so that's the approach you want to take. So the approach you want to take at this point, I'm going to say R here. The approach you want to take here was to make, first of all, make the exponents positive. All right, make the exponents positive. What's the next step, though? What rule are you using? Quotient rule. So this time, though, you're going to say x to the first, subtract what? No. 4. Well, what's 1 minus 4? So notice you get the same thing, right, at this point? That's it? So what's the answer? 1 over x to the third. Okay? All right, anything else you want to try? You thought about doing? That's probably the two main ones that you'll try first. Okay? All right, so 16. Let's look at 22. 22. You have negative 1 divided by y to the negative 6. Negative 1 divided by y to the negative 6. All right, do you have any negative exponents? Yes. So make it positive. Where are you going to put it? There. So first of all, what numbers in the numerator? So that's negative 1 times y to the 6. So you can since the coefficient is negative 1, you can just rewrite it as what? Negative y to the 6. All right. So that's 22. Then let's look at this one. Yes.
So we only switched the base of, like, say, this x and y to the numerator or denominator if it's negative.
If the exponent is negative.
Oh, okay.
Exponent. Right. So in this example, let's look at this example. Suppose you had negative 2 divided by x to the negative 5th power. Do you have any negative exponents? Yes. The x is the only thing being raised to negative exponents. That's the only thing you fool with. Everything else stays where they are. So is the answer. X to the 5th. Negative 2x to the 5th. Okay? All right. Then, let's see. I'm trying to, so part A, worksheet part A on this. I'm not sure I covered everything. There's a couple more things though from that. Okay, well, listen to this. This is going to be number 6. Well, first of all, before we do number 6, let's do this one. Suppose I had 3/4 to the negative 2nd power. 3/4 to the negative 2nd power. And to make it difficult, think about how you can approach this.
1 over 3/4 to the 2nd power.
Okay, that's one approach. So that goes back to one that we did earlier. If I can find the step where someone had mentioned 1 divided by. I probably can't find it anymore. Because right here, remember we did 1 over 3 to the negative second power? So someone said we got was 1 divided by, and we proved negative second power is 1 over 3 squared. So that's the approach that she's taking. So one approach is to say 1 divided by 3/4 to the second power, right? But what's 3/4 to the second power? Come on. You need a calculator for that? Yeah, 3 squared is 9. 4 squared is what? 16. You don't need a calculator for that. So it's 1 over 9/16. And then how do you deal with 1 over 9/16? Change the multiplication problem. So remember, that's 1 divided by, so change division to multiplication. So that's going to be 1 times the reciprocal of 9/16, which is what? 69. And so what's the answer? 69. Now that was one approach. What's another thing you could have done?
We don't simplify 69.
You can't. It's simplified. They don't have the only factor they have in common is 1. What else can you could have done? Now I want you to notice this. Doesn't this kind of look like the power of a quotient?
Yeah.
So the numerator, I can raise to that power. So 3 is being raised to what power? -2. 4 is being raised to what power? -2. Now let's talk about rewriting the exponents as positive. The 3 is being raised to what kind of number? Where is it located? Where do I put it? Denominator. So that's 3 to what power in the denominator? Squared, good. 4 is being raised to what power? Where is it located? Where do I put it? What's 4 squared? What's 3 squared? That was probably the better approach I've taken. Using the power of a quotient. So you take the numerator raise to that power, take the denominator raise to the power, and then you make the exponents positive. Okay? All right. So when you have a fraction like this that's being raised to negative power, it's probably best to use the power quotient first and then make the exponents positive. All right, so I was going to take us to number 6 now. Here's number 6. We have -1. Well, it's -1/5. That's the way it looks. That's 1/8, sorry. 8. -1/8, like this. And that's raised to the -2nd power. It doesn't matter which approach you take, you can use the English approach we just talked about. So what do you want to try? Okay, so we do that first. Let's talk about that negative that's out here. You may want to actually associate it with either the numerator or the denominator. Usually, though, we associate it negative with which part? The numerator. So in other words, I'm going to rewrite this as this again. -1/8 like this, raised to the -2nd power. Okay? All right, now. So if you're going to use the power quotient, then this becomes -1 to what power? Good? And that becomes 8 to what power? All right, so notice what I did. Okay? Now let's talk about making those exponents positive. -1 to the -2nd power, where do I move it? The denominator. 8 to the -2nd power, where do I move it? Numerator. So now my exponent's positive? Okay, so what's 8 squared? What's what's negative 1 squared? Good. So what's the answer? 64. That's the answer. If you wanted to use that other approach where you say 1 divided by, you have to do this. You have to say 1 divided by negative 1/8 raised to what power? Second. Okay. So that's 1 divided by, what's negative 1 squared? What's 8 squared? And then you use something you did last semester. So when you're dividing fractions, you change what kind of problem? So that's 1 times the reciprocal. What's the reciprocal of 1 over 64? So what's the answer? It does not matter which approach you take. It does not matter. All right, number 8. You want 4 to the negative 1 plus 4 to the negative second power. All right. The 4 to the negative 1, how do you rewrite it? Which is just what? 1 over 4. 4 to the negative second, how do you rewrite it? 1 over what? 4 to the second. What's 4 to the second? 16. So that's 1/4 plus 1/16. So that's that, right? Okay. But you got to add those fractions. So last semester, when you added fractions or subtracted fractions, your denominators had to be the same. Okay, the denominators are different here. So what's the LCD? 16. So then remember you wrote equivalent fractions. So you're going to write 2 fractions with 16 as the denominator. So then what you didn't do was you said, well, I need this 4 to become 16. So you said 4 times what 16? What I do to the denominator, I have to do to the numerator. So what does this become here? Kind of makes sense because 4/16, if I reduce it, is 1/4. Here, the denominators are the same. So that means the numerator is going to be what? So what's the answer? 5/16. And you can check your calculator. You can check your calculator. So you're going to say in your calculator, you're going to say 4 to the negative 1. Look how simple this is. 4 to the negative 1 plus 4 to the negative second power, press equal, and you get this decimal. Convert the decimal back to a fraction. So second PRB, press equal, and you get what? 5/16. Okay? That was 8. I'm trying to make sure I get everything on that part A. Let's look at 24. 24, you have 5 to the 0 power plus negative 5 to the 0 power. And then it looks like there's a negative 5 to the 0 power. Alright, so what's 5 to the 0? 1. What's negative 5 to the 0? So what's the answer? Oh, now negative 1, negative, anything raised to 0 power is what? 1. And what's 1 plus 1? 2. So the answer is 2. Okay. Alright, and one more. Let's write this example. Alright, suppose you had x to the 5th divided by x to the negative 6. What do we use? So you want to do first thing you want to do is make the exponents positive. You could have also done what first? Quotient rule does not matter. So you wanted to make the exponents positive. So that x to the negative 6 is located where? Located where? Where do you put it? Numerator. So it becomes x to the 5th times x to what? 6. So now when you multiply on bases, you add exponents. What's the answer? X to the 11. If you had used a quotient rule, same thing, right? So the quotient rule rule says we divide like base, you do have those exponents. Subtract, so you say x to the fifth, subtract a what? All right, be careful, you're saying 5 subtract a negative 6. So that becomes 5 plus 6, which is what? 11. Right, so it does not matter which approach you take. Okay? All right, so that's going to take care of worksheet part A. And so in your study guide, there are how many problems? I said 2 problems? So 2 problems that look like this on your test. It's not difficult. All you do is just remember those 2 extra rules about negative exponents. Okay? All right. Now let's still, I haven't picked it up yet. All right, so now, still this section, we're still doing this section. It's going to get, the part B is going to get a little bit more challenging, but it's not that difficult. As long as you understood what we just did, you should be okay with what we're about to do. Okay. So this is where we're going to really start using the stuff from the previous section and the negative exponent properties, the rules. So this is 26. And that's going to be the part B worksheet. Okay, so you have y to the 4th, y to the 5th, divided by y to the 6th. Don't make it difficult. Think about different approaches you can take. What are you going to do first? Say it again? Tell me what rule you're using. The product rule. You're using the product rule, which part of this fraction? The numerator. That's exactly what I would have done first. Y to the 4th times y to the 5th is what? Y to the 9th. Product rule in the numerator. Now that looks like what we just did. What's the next step? Tell me the rules, guys. Y'all know your rules. What the quotient rule is next. Quotient rule is next. So we divide like bases, you do what to those exponents? 9 minus 6 is 3. Okay? So that was 26. So this is where we're going to start using a combination of properties, combination of rules from last section and this section. 28. This time you have y cubed times y divided by y to the negative 2nd. What are you going to do first? Come on, try something. Okay, so that's one approach. So one approach is to deal with the negative exponent first. So then that becomes y cubed times y to what power? 2nd, right? Then, seeing this, then what rule are you going to use next? Product rule. So when you multiply like bases, and I am, you do it as exponents. So that's going to be y to what power? Not the 4th. The 6th. You add the exponents. What's this exponent right here? What's this exponent? 1. What's this exponent? 2. So it's y to the 6th. So that's one approach. Let's do this problem the same way we did number 26, though. So let's look at the other approach. What's y cubed times y? The product rule. Y to the 4th. Divided by y to the what? Negative 2. Now let's use the quotient rule. So it becomes y to the 4th subtract what? Negative 2, which becomes y to the 6. Okay? Now use the quotient rule, right? But you could have also done this. You could have also said, all right, I'm going to use a product rule first. So y cubed times y is y to the 4th divided by y to the negative 2nd. Then you can go back to what some of you want to do. You want to say, well, let's make those exponents positive. Okay? Well, where's y to the negative second going to have to be brought to? So it's y to the fourth times y to the what? Second. When you multiply like bases, what is exponents? Get y to the sixth still. You see that? So different things you can do. You have to know those different things, though. You have to know how to deal with each approach. Okay? All right, number 30. Number 30. So number 30, and then we'll stop there. Number 30, you have this. Let's think about how you're going to work with this one. X squared to the 8th times x divided by x to the 9th. Tell me what you're going to do first. Tell me the rule that you think you're going to use. The power rule. The power rule. You're going to use the power rule with this right here. This. X squared to the 8th. When you have a power, it's a power to those exponents. So this becomes x to what power? Times what? Very good. Divided by what? And now that looks like 26. This looks like 26. What's the next step? Don't do the quotient rule first. The product rule first with the numerator. What's x is 16 times x? Divided by. Now use what rule? Very good. So then that becomes x is 17 subtract what? And what's 17 subtract 9? 8. And there's your answer. It's not that difficult. It's not a very difficult concept dealing with negative exponents or exponents in general. Just as long as you know your rules. You have to know your rules. If you don't know your rules, then you're going to struggle to know what to do. The rules kind of tell you how to deal with each part. Okay? All right. Make sure did y'all start? Okay. All right. So